Good afternoon or good morning, depending on which part of the country you're living in. Welcome to the first ARISO webinar for 2025 on digital engineering. So thank you very much for joining us today. To start with, I'd like to acknowledge the traditional custodians of the land in which we meet today. For me, I'm in Rockingham in Perth, which means that I'm on the land of the Whadjuk Noongar people, and I'd like to pay my respects to their elders past and present. I also extend that respect to Aboriginal and Torres Strait Islander people with us today. So today we are going to look at implementing AS7739, the digital engineering standard, and how it improves productivity through technology. Today's webinar is particularly significant because it's the first webinar that we're delivering under our new name, the Australian Rail Industry Standards Organisation, also known as ARISO. Many of you may have known us for years and years as RISB, and whilst our name has changed, our purpose hasn't. We are still here to serve the rail industry by developing high-quality, industry-led standards that support safety, interoperability, and productivity across our rail networks. The timing of this topic could not be more appropriate. Under the new NTC National Rail Standards Framework, ARISO is now an enhanced role as the industry-led technical standards organisation, not only developing harmonised standards, but also supporting their consistent adoption and practical implementation across projects and networks. And that's what we're going to talk about here today, is around that adoption and practical implementation. So this is a critical shift for us. Standards only deliver value when they're used in the field. Implementation, capacity uplift, and application are now the major focus of ARISO's work, ensuring that standards become real tools for achieving safer operations, better interoperability, and higher productivity outcomes for the industry. Which brings us today directly to our session. AS7739 Digital Engineering Part 1 and 2 is a perfect example of a modern standard with the potential to drive genuine transformation, aligning technology, data management, and project delivery to a consistent national approach. But like many technical frameworks, the true challenge lies in bridging the gap between the theory and the actual execution. This webinar is exactly about doing that, turning the requirements of AS7739 into something that's practical, scalable and usable on live rail projects. It speaks directly to ARISO's renewed focus on helping industry move from standard publication to adoption, unlocking that productivity benefit that standards are designed to deliver. So today we are fortunate to be joined by Simon Vaux, the primary author of AS7739 series and a recognised leader in digital engineering implementation, who will take us past the concepts and into the realities of using digital engineering standards and getting digital engineering outcomes. So Simon is widely recognised as a digital engineering pioneer and subject matter expert, and is the primary author of the AS7739 series, the national standard for digital delivery in the ANZ rail corridor. As the CEO and co-founder of DIOS Digital, he provides strategic consultancy for major infrastructure projects and government agencies. I would now like to hand over to Simon for our presentation today. All yours, Simon.
Thank you so much, Chris. And good afternoon and good morning, everyone who's attending from around Australia. So I'll just share screen and get the slides going. So yeah, look, it's really exciting to be able to give this presentation. I've just been going through and seeing who's on the call, and it's great to see a few familiar faces. I think today we have a pretty interesting story to tell. So today's presentation will run for about 40 minutes or so. There'll be time for Q&A at the end, and the slides will be shared on the ARISO website. And I believe also the presentation will be recorded. So just a little bit of background for those who haven't met me. So my background is in civil engineering. I started my career working as a bridge designer. And I got into the railways when I was working with Transport for London and the London Underground. In 2007, I joined Transport for New South Wales in a design management capacity, but over the years I moved into creating the digital engineering team and delivering the digital engineering framework. About 5 years ago, I left Transport, and since then I've been consulting with major projects, government agencies, and a variety of other organisations, including academia, over the last 5 years, mostly around ANZ, but also abroad. But one of the really interesting projects I worked on was with RISB at the time, now ARISO, on AS7739, which is the topic of today. So the presentation is going to cover 5 main topics, and then we'll have Q&A at the end. First of all, I'd like to start, as I often do, by just framing what is digital engineering. It can seem like a fairly ambiguous topic, fairly broad, so we'll try and nail it down with a few sort of key points. I'll then talk around what is the productivity and benefits that digital engineering offers. I'll provide a recap of the ARISO standard AS7739, parts 1 and 2, what was in it, what's the purpose of it, and then how does it actually work on projects. And then finally, I'll talk about a real-world example where AS7739 is currently being used. And this really takes the concepts and technical sort of intent of AS7739, but then builds it into quite a digital solution. So plenty to discuss, so we'll get right in. First of all, what is digital engineering? I use this slide to often describe many different activities over the asset lifecycle, from network planning, asset design, project management, all the way through to customer service and asset renewal. Now, it doesn't really matter which stage of the project or asset lifecycle you're working in. These days, everything all hinges on quality data. So in many ways, whatever work you're doing, it is all a data management business. Now, when we talk about the asset lifecycle, the current way in which data flows over the lifecycle tends to be disconnected. We have many different lifecycle stages, each typically procuring information for single phases of the lifecycle. So design information not necessarily handed over in a clean way for reuse in construction. A whole bunch of construction information not cleanly handed over for operations and maintenance. And so we end up with a patchwork of data procurement, but poor handover. So the asset lifecycle of data is often manual, unstructured, siloed, inefficient, and prone to human error. The nirvana state, where do we want to get to? Well, there is this concept of the golden thread, digital thread, is often another term, that hinges on structured data. Now, what that really means, what is structured data? It is often described as tabular data or data in a database. A database that is controlled and make sure that the data is accessible, secure, but it's reliable. So data flow down the bottom is automated, standardized, centralized, optimized, and as I mentioned, is reliable for reuse over all stages of the life cycle. So this is where we want to get to. How do we get there? That's the main topic of today. So what is digital engineering? Many definitions out there. You often hear in some circles BIM/DE, as in one is comparable with the other. But I'd like to give a different angle to that. We already have in industry, there are 3 main bodies of knowledge that, I'm sure you've probably all heard of. For project management, we have PMBOK. For asset management, there's AMBOK. And they both are considered, real headline documents for defining what good looks like. In data management, what's lesser known is the DAMA, Data Management International Body of Knowledge, DMBOK. Now, when we were first looking at scoping up digital engineering for the ARISO standard, we had to come up with a definition. So I looked at taking a piece from all 3 of these other key bodies of knowledge. So the definition that we landed on is that digital engineering is a collaborative way of working using semantic data management to enable more productive methods of project delivery and asset management. So let's expand on that. We already have ISO 19650, which does it provides a lot of description. It's very comprehensive around this topic of information management. And if you go to figure 1 of part 1, there is this diagram which talks about three main stages of digital maturity, and it pictures ISO 19650 at stage 2 maturity. This is where you have sort of container-based information, information in a common data environment, but it sort of leaves over the horizon the creation of stage 3. Now, ISO 19650 doesn't really describe what stage 3 is all about, but this diagram does suggest that it involves the ability to have data that you can query. It mentions databases, and there is also an increasing role of big data. Now, when also we're scoping up AS7739, we started targeting, well, what does stage 3 look like? How do we move beyond what ISO 19650 describes as good to then start building stage 3? What does excellent look like? So one of the big leaps and the big changes away from traditional approaches to what AS7739 describes as digital engineering is a move away from the BIM-centric approach. This is really the predominant way of working when BIM first became a big thing, where BIM was at the center of your project. And so you have all these different BIM dimensions as such, and a common data environment that hinges on importing and exporting of files or information containers in and out of your common data environment. The key change that we were introducing with AS7739 is instead of a BIM-centric approach, we started really describing a data model. So instead of BIM dimensions, we're talking about database dimensions. And for those less familiar, it's worth looking into how databases are designed. AS7739 really got to the heart of this and started considering a database at the center of the project using a common data model. So how do we then connect into different deliverables, different data sets? Once you have a database at the center, you can start designing database queries or APIs to then link systems together. So another definition for this is a data-centric approach, having a database at the center. So how does digital engineering improve productivity? Well, some of you may have seen this diagram before, but even after all these years, it's still very relevant. Where the current approach, the predominant way of managing information has often been around file management. On rail projects or just any sort of infrastructure projects, we'll have all these different deliverables that are being procured on the job. Each, will often be procured as files, so surveys, CAD, drawings, BIM models, asset registers, but each with their own inherent coding systems. But none of these coding systems are ever designed to talk, so what you end up with is a fragmented ad hoc ecosystem. So the future state, when I was at Transport for New South Wales and we started imagining the way the digital engineering framework would actually work, we started looking at not file naming or just file formats, but the metadata that we can use to link things together. The inherent data inside the files, or even in a document management system, the metadata about your files. So where we got to, though, was to design a series of data dictionaries, data specifications with spreadsheets. Now, spreadsheets are good. They're flexible, easy to use, but that's not modern data management. So what we started imagining with AS7739 was instead of spreadsheets at the center, database at the center. A database where we can link different systems together. And you start treating everything in a lot more of a digital sense. So over the life cycle, how does this look? Well, coming back to that current state, of file management, the project is split into all these different stages, each with gates. So you get through demand need, you have an approval gate to start planning, and you finish planning, you get through the gates to do design and so forth. Now, often, files are the predominant way of gathering, procuring, specifying the data that you need to deliver each stage of the life cycle, but there's not a lot of thought about how that would be handed over for reuse at later stages. When we get to operate and maintain, that's when we start thinking more around databases, So each operator maintainer would have their own asset management system, their SAP, Maximo, Ellipse, or many others. But that requires a population or populating these databases with metadata. And often that metadata would be created, would be built and entered into these systems manually at that point of handover at the end of the project. But there isn't just one handover. There's a handover at each stage of, well, between each stage of the life cycle. So the future state, which is where we started working towards with 7739, was to imagine a connected digital ecosystem where we start connecting the different deliverables together by designing a data model that would link things together. Now, if we start linking multiple lifecycle stages together, then we start achieving this concept of the digital asset lifecycle or the digital thread. To do this, we have to start designing what is that payload of metadata that we hand over between lifecycle stages. The benefits in return is that we can then query backwards. We can know historically anything about any of our assets over all stages of the life cycle, which is very difficult if you just have a file-based approach. Now, to design this, as I mentioned, we have to start imagining or designing that common data model, a database design that carries through all life cycle stages so we can link things together. And this is really at the heart of AS7739. So a recap of the standards. So the standards were developed mostly over 2021. The standards were split into two parts. Part one was around concepts and principles. I'll get into detail in a few slides. But then part two was released about 2 years later, where we then got into the technical requirements. How do we take the high level ideas and then bake them into instructions that anybody could actually follow? Noting that even if you follow the instructions, there's a degree of technical know-how, which we'll get into later on. The development of these standards, I felt very privileged to be the author of these standards, but also work with a great team. There were close to 30 different organizations from across private sector, various engineering consultancies. We had public sector with various government agencies. We had academia with several universities, and even industry bodies such as Building Smart. So together, we're able to achieve something really quite special. And so for those on the call that were a part of this, just want to say a big thanks. It was great working with you on this one. So part one, what was it all about? As I mentioned, concepts and principles. If you haven't read it, strongly encourage you to check out the ARISO website, get yourself a copy. Part one introduces the why, the what, the who, and the when at a very high level. It talks around some of the concepts I've already introduced. It provides guidance that introduces new concepts, terminologies, conventions that are required to standardize digital engineering for the ANZ rail industry. And it also explains how to build data management capability and the overarching digital framework required for successful digital engineering implementation. Data management is such an important capability that, in my view, I think it's still emerging. We have a lot of our sector is really familiar with the concepts of 19650, but lacks the terminology that every other sector outside of the engineering and construction sector uses. If you look at any other sector, how they describe data, it's quite different to the information container approach of 19650. And some of that terminology that is really useful from other sectors started introducing into the standard. And that's why I strongly recommend having a read. 5 key takeaways of part one. First of all, part one provides foundational guidance for rail asset owners. Introduces concepts and principles. It's not intended for direct reference in project procurement contracts. You can't just say, follow AS7739 part one. It's more high level than that. Secondly, digital engineering is a new collaborative data-centric approach to project delivery. It provides a clear distinction beyond BIM and general information management. As I've already noted in this presentation, we're trying to move beyond the BIM approach to something that's more ingrained in, or has data management as something more at the heart. The goal is to achieve the connected digital ecosystem, which requires a shift away from file management, more towards data modeling, database design. So in order to get databases talking, then we start getting into semantic interoperability. So how you can achieve automation by getting things to talk. And one of the key recommendations was that uniclass is required as the classification. This is something that, as a group, we collectively landed on that would allow us to accelerate the uptake and outcomes from these standards. So part two, I'm not going to get into detail with the limitations of this, with the time we have today, but the two key parts of AS 7739 Part 2 technical requirements was, first of all, the common data model, and secondly, the data dictionary. So the data model is really something that people may have heard of data modeling, but I have seen that there's still a degree of uncertainty as to what a data model is. So let's just spend a few minutes explaining that. I'll use a concept of, I want to talk about data and metadata first of all. And I'll use the analogy of a box of cornflakes. So just imagine you went to a supermarket, you want to buy cornflakes, and all the packets look like this, blank with no labeling. Well, you wouldn't know which box of cornflakes to buy. You wouldn't know the ingredients. You wouldn't know, if they're good or bad. You wouldn't even know if they've reached their expiry date. And so it'd be really hard for you to make a decision about which ones to purchase. Thankfully, that's not what things look like. When you go to the supermarket, they look more like this. The packet is covered in metadata, from the branding to the nutritional facts to even the barcode. And metadata is what gives this packet its value. You know which one you want to buy. And so data modeling is really a specialized activity that designs the consistent architecture or structure of metadata. How do you design the way metadata will work, not just for boxes of cornflakes, but for data management? And so data modeling, what is a data model? I've worked with a variety of different clients, and often if I've started to talk around data modeling, there's often people in the room who'll say, yeah, we're already doing that. But scratch the surface, and what they are really describing is often laser scanning or point clouds, photogrammetry, GIS, or BIM. Now, these do have a model, a 3D model, and they typically involve metadata, baked into the GIS or BIM in particular. But none of these things constitute a data model. A data model, its full name is often an entity relationship diagram, is really the schematic of how you're going to design and build a database. Very, very different from any of these other examples up on the screen. And data modeling is a completely different skill in its own right. It's got its own type of vocabulary. You can pick it up pretty quickly. Like, there's great YouTube material on there, but this is really the starting point. How do we design the way a common database should work? And so when we started designing the database structure in 7739, we looked at four main domains: commercial information, work packaging, physical assets, and information deliverables. I used a Venn diagram just to try to represent it because it's easy just to show it something like this. But four key domains, and these domains would carry metadata that will work over all lifecycle stages and allow data to be linked. So, on a really basic data modeling sort of high-level concept, just think of it this way. One contract has one or many work packages, and that's what this sort of crow's foot notation is trying to suggest. So when you have a contract, you put out a contract for design, for construction, it'll have work packages. And each work package has one or many assets, and it has one or many information deliverables. And so that's the basic architecture of this data model. And so inside that, you start to unpack that a bit further, and there's all these, smaller components that all form part of these four main domains. So for the contract itself, you have contract information, the contract type, the project level, the project lifecycle stage, and the engagement type. There's various other opportunities for further expansion, but these are the main sort of components that were in commercial information. For work packaging, what are the different types of work packages? So I'd say the work breakdown structure, your work zones. We looked at various global standards that also give definition for work packaging. For physical assets, this is when we start talking about location breakdown and asset breakdown, both of using Uniclass, but also potentially clients' own local systems. And finally, information deliverables. This is when we start talking around geometric information, non-geometric information. Think of it, the bottom right quadrant. This is your information containers or your files. And just to be a little bit controversial, this is where I believe BIM lives. It's a form of geometric information, but not at the heart. The heart is the database that allows things to talk. So with all these things combined, we have a schematic. Now, this isn't necessarily using any modeling notation, but it's where things start. The other thing to note is that in the bottom left-hand corner, I mentioned Uniclass. We considered many different solutions, and if we want to actually call out the use of a classification. Now, after a lot of meetings and discussions, we all agree that Uniclass provides more coverage, so it's got more breadth, and it's also got more depth than any other classification that's out there. At the moment, it stands at about 18,000 objects inside the Uniclass classification. Every 3 months, more is added in. If you find something that's missing, you can talk to the team at MBS, now called Hebexo, and it continues to grow. It's such a body of knowledge. It's a separate conversation. So it has the level of detail that's essential for CapEx. There's often many other classification systems out there that don't have the granularity you need for plan, design, build. We'll sort of get into that a little bit later on. It's also the universal digital language that can be mapped to other systems. It's great because of its flexibility, you can build out breakdowns that you need, and then you can easily connect into other systems. Now, one last thing I'd say about Uniclass is it's well known. I think most people have heard of Uniclass, but I really think there's a need for greater understanding. Part of that's NBS. They haven't really communicated smart ways of using Uniclass, which is one of the things we'll be discussing today. Okay, enough of the theory, enough of the background. Let's move forward and talk around, how AS7739 works on a project, and also we'll talk about project implementation. Just want to note, traditionally, the way Uniclass is often used on projects, in a BIM sense, the typical workflow is that you create your 3D model first, and then you tag it with Uniclass, or you tag it with any other metadata that you want. And that often requires a degree of manual data entry. So 3D modeling, and then tag, tag, tag. And just as an example, this is a screenshot from Revit, where you can add in whatever classifications you want. So you can see here, you can put in element function, put in the system, or put in product Uniclass codes and descriptions manually. And this is the way the BIM approach has been for some time. The 3D model comes first, and then we tag it with information. And the new approach that we really started getting into in AS7739 is build a database first. Build your asset register in a sense first. And this may be built up over multiple lifecycle stages, but you build that database, before you start doing your 3D modeling, because you'll know as a client some of the scope, and then you have this sort of dance of more scope, more design. You identify more assets, and you move through the sort of V cycle in systems engineering. Now, this database, the structure of it, I've got the little symbol over here. The design of that database uses the schematic from AS7739. Now, I've got a logo here for Twin Engine. This is a platform that I have been working on to actually implement 7739. So the benefit is that once you build that database, then when you go to your 3D modeling, instead of getting into your 3D objects and then tagging it with all your information, you can automatically populate your BIM model using a combination of globally unique IDs or GUIDs and an API straight from the source. So this greatly reduces the manual data entry that would typically be required using a BIM approach. So I'll give you an example because like that's quite symbolic. We'll get into more detail into something a bit more tangible. The next thing I note is that uniclass, as I mentioned, there's a need for greater understanding. One of the things which AF7739 introduces is the concept that you don't use sync codes, uniclass codes in isolation. You can link multiple codes together to start with monolithic level classification down to something that's very granular. So a complex is composed of entities, which is composed of spaces. But more than that, there's this recursive relationship. A complex may be composed of subcomplexes. Entities may be composed of entities. Spaces may be composed of further spaces and locations. So you're not just talking about three distinct levels. You can have multiple levels. You can have a whole string of codes linked together. And same goes for assets, element function systems products. So let's give you a little example. Just imagine you want to locate some office furniture in an office building, just using this approach. So your building itself, everything inside the property boundary, that overall tower is a complex, starting from anything inside the property boundary. Now, that complex will be comprised of one or many entities. So one of the towers, that's an entity. And then you carve that entity into a series of spaces. So first of all, levels, and then your levels have, say, open plan offices. So this is starting very monolithic down to a specific office. And same goes for furniture. You'll have your element function for furnishings, which is composed of office equipment systems, which is composed of workstations, and a workstation, one of the components of that would be an office chair. Now, what I'm showing you here is not classification. It is how you use classification to achieve this other concept, decomposition. Classification used for classes and subclasses. Decomposition is used for joining up the components of things. And so just imagine then, I'll give you another example here. We've got like a pump, centrifugal pump, that might be sitting in a storeroom or machine room of a metro station. So we have a location breakdown and we have an asset breakdown. And both of these things combined will be used to reference an individual pump or any other component. Now you can see here we have the uniclass codes, but we also have the instance names for things. And that's an important point that is introduced in AS7739 is that classification, but then you also have your instance naming as a separate thing. Now, in reality, we don't want to be typing out uniclass codes and everything over and over again every time we create things. What we want to do is create this once using a simple user interface in a database somewhere, and then just use a single code, a globally unique ID. Think of it like a barcode, a virtual barcode. You can drop that into your BIM model, and then you can exchange, you can API all this data from one central source. So you're not having to do all this manual data entry. You can just do it once. So, just another way of representing that then is that your database then becomes a whole grouping of globally unique IDs that are structured using these breakdowns with uniclass. You can then use an API to then, well, you drop these GUIDs into different deliverables and you can API data from the source. So an API is essentially just, think of it like a text file. An XML file or a JSON file just lists out all your metadata, all your attributes. So from a single globally unique ID, you can exchange all this other information into many other systems, all coming from one primary source. So this is the real benefit that AS7739 offers, this hierarchy, like this centralized data management that can then be exchanged out. So on a project, just think you have many different project roles. You have many different project deliverables. Now, if you say had an asset and you want to find out all this information, find me all the information about this phone, you'd have to be a detective, or you have to talk to all the different specialists to go into each of the different systems to find data about an asset. But if you have a central database, that becomes the node, the hub, sorry, and everything else becomes a node. And so by using the common data model to have your standardized central database, you can an API, and over time you build in APIs to more and more technologies that you can then link to. So for each of these different owners, they want to have different dashboards depending on what activities they're doing, commercial, project management, design management, whatever. They all have a single view of truth. So you can build Power BI databases or dashboards, sorry, business intelligence, or even being the foundation for artificial intelligence, all coming from one central hub that is reliable. And this is, just a little nod. This is what the opportunity is provided by Twin Engine. So as I mentioned, you've got this one central hub using globally unique IDs. You can then ask all sorts of questions about your assets. So how much did it cost? Where is it located geospatially? What assets have been built so far? Is it on time? You get the idea. This is the real benefit of having data that you can query, that you can API, that optimizes the way your projects work. So this is really the opportunities that were initially laid out in 7739. So let's talk about a real world example. So lately I've been working on a light rail job. Just this presentation is anonymized as such, but working with a contractor to deliver light rail extension. So the challenge is that it's one project, but it's interacting with many different asset owners that are both public and private. Each of these stakeholders has their own asset management system, and each of these asset management systems is discrete. Each with their own levels of granularity, their own needs as such, their own requirements. And so we had a need for a central database that can be mapped to other systems. So how does that work? Like if you just look at a cross section of the projects, we have the light rail operator. So the light rail operator has their own assets down the center of this road. We have the local government that looks after the roads, the street lighting, the verge, and other aspects of the project. We have public and private asset owners, landowners, parks, various other things. And then also underground, we've got various utilities that are used to both operate the light rail, the road signaling and communications, plus also all the utilities, telecoms, power, water, sewer, gas. We got the lot. Now, each of these different organizations, each has their own system. Like they run their own, they run their own businesses and they have their own ways of working. Initially, when I started on the job, I started gathering what are the different classifications that each of these different organizations use. And I've noted this over many years of working with different organizations. Often the the asset classification standards are developed by the operator maintainer. And they classify based on how they will maintain the assets, which sits like that totally makes sense. But what you end up with is often classifications that suit operate, maintain, but they're not necessarily very applicable for plan, design, build. I'm going to give you an example. The light rail operator, if you look at their classification standard, there's 342 different classification objects in there. But if you look at, say, bridges, they've got two codes, bridges, and then a subclass for overbridges. That's it. So if we want to, we are going through plan, design, build of bridge structures, this isn't enough to describe all the different components of the bridge. Say local government, there's an agency that we're working with. They have a classification system with 380 different objects in it. So for bridges, they've got 6 objects, bridges, and then 5 subclasses of bridge, which once again, it's better than the light rail operator, but it's still not enough. Then we have various other organizations. One of the organizations have got close to 4,000 objects, very granular. They've got 308 objects for describing, breaking down bridges. So everyone's got their own way of working, and that's all fine. Like we're not here to change the way they work. They've got their own businesses to run. What we want to do, though, is to create one asset register based on AS7739 that works by mapping to the other systems. So we can create one asset register, and then we can easily link to the other systems. So how do we do that? Well, first of all, we use Uniclass. We build out asset and location tables. think of this as standardized breakdowns. So we use the twin engine platform to drag and drop to build out these asset breakdowns. So element function systems, products, we do the same for locations as well. And then we map these standardized breakdowns. These are the breakdowns we need for plan, design, build, and then we translate those to the other systems. Now, this isn't the asset register. These are standardized breakdowns, but we have this mapped. So whenever we describe anything, we can easily then translate, well, here's that same coding for the light rail operator or for local government or anything. So then when we use these standardized breakdowns together, location breakdowns, asset breakdowns, we combine them to then building the asset register on the job. The great thing about that, because this is all now standardized, where these are the only combinations of uniclass that will permit, we can easily then, through automation, push a button. Here's this same asset register that suits the light rail operators, asset management system or local government or any of the organizations that we map to. So this takes out a lot of that pain of building multiple asset registers later on or trying to understand what everyone else needs. We just build it once, map it, and then we can translate easily. So if we look at technologies over the project, on this job, we have a range of technologies through design, construct, test, and integrate, and operating phase. And we have all these discrete technologies that all serve a purpose. So for design, the design is saved on Econex. We have ArcGIS, Revisto, and 12D. For construction, we've got separate system for work lot management, and for scheduling for construction, we've got various systems for completion tracking, for asset registers, for managing the RADM, and so forth. As I mentioned, the operate and maintain phase, different asset management systems. So there's a real need for us to avoid the headaches of just managing files alone and then trying to work out how to hand stuff over to the next stage, because it's going to be a real pain point to then have to continually sift through just data dumps of files that don't necessarily link to anything. When we get to operate and maintain, then we'd have a real challenge with having to take all these files through that have been created at different stages and then trying to populate different systems, trying to work out what they need. The alternative is that we build the asset register using AS7739 as that design of the database. So we have all our files that we're creating through different technologies, but we're linking them through this connected digital ecosystem. Then during construction, we're using that same database, that same asset register, and then we can then query back through the design. So, when we start creating work lots, we can then say, okay, well, find me the drawings associated with this asset. Easy. If we wanted to do things like, all right, I've got this asset, show me where it is on GIS. Or show me, at what stage in the project schedule is this asset going to be built? When is it scheduled to be built versus actual? You can start linking different systems together because of this thread along the top. Same for testing integration. And the real kicker is when we get to handover at the end. Because we did that mapping up front, using standardized breakdowns and mapping to the other systems, that handover into the various operate and maintain systems is no problem. So I describe it, it's a bit like having a conveyor belt. This digital thread or a conveyor belt where each stage of the life cycle we have a smooth transition. So last slide, and then we'll open up to questions. I'll just give 5 main outcomes. First of all, using this approach has really improved productivity. This approach really enables a rapid exchange of project or asset data over the complete asset lifecycle. We're not just managing or handing over files. That database allows you to reach in and query the data inside those files. There's a degree of satisfaction. By having automated workflows, we've really been reducing the amount of manual project admin. People that would manage spreadsheets a lot of the time can now be relieved of that burden because we have automation. And they can get onto more interesting parts of the project. Insights, reliable data can be queried or analyzed over the life cycle. It means that we can start doing better trend analysis, better understanding of our projects. Communication, by building out the asset register as early as possible, we can provide early notification to the asset owners or the asset operators, here's what assets you're going to receive. Clear intent, so they're ready on the other side for the handback. And finally, innovation. By setting this up, there's the opportunity for continuous improvement and for further technology integrations. We're looking at further API connections for both pulling and pushing data into various technologies, well, the communication between them. So exciting times, but really AS7739 has really been at the heart of it. Now, that really concludes the presentation. I appreciate you guys sticking around to join us today, and happy to open up for some Q&A. Thank you.
Great, thank you very much, Simon. And it's great to see some practical applications from all that work that we did on 7739 those years ago. So it's wonderful to see that the standard actually being used in reality. Just got a couple of questions while some others are looking at the Q&A and maybe dropping some questions in. One of them is, what, from your point of view, what practical steps should asset owners take to uplift their digital engineering capability across their project lifecycle? And particularly when you're dealing with maybe the small to medium contractors, how do you sort of bring them into the fold?
Yeah, look, great question. Like the starting point is having an honest look at how data flows. Before getting into technologies, I know like technology is the shiny thing, but it's really important to first map out your processes. The approach that I'd often take with different organizations is designing the way your process needs to work, because that sets the requirements for how you specify your data. Designing that data model, what we did in 7739, then sets the requirements for how your technology needs to work. So it means that you're using technology that supports your business processes. The alternative, if you just get straight into, right, we're going to buy some technology without having those top-down requirements in place, it means that technology drives the way your business needs to work. And if you don't have clear requirements, clear intent in mind, you may be trying to shoehorn your business into technology that may never have been designed to work the way you intend. So, it's just important to appoint somebody internally who's going to be a champion and get them to start mapping out your processes. Find somebody that's got some enthusiasm in this space, has a degree of curiosity, and can start mapping out processes to work out, just designing on paper, where do you want to go with this?
Yeah, great. Thanks, Simon. We've got quite a few questions coming in. So I'll ask the first one. What is the upfront cost to set up databases as shown in this presentation? And how, in your experience, can you justify the overall cost within the project?
It's not a big cost. Cost isn't the big thing. Wasted human resources is a huge cost. The cost of setting up the database is a fraction of what it would cost if you are producing all this information that just ends up in a dead end. The alternative is, we'll talk about that first of all, the cost of procuring a BIM model where it's saying, I want to have all this data inside BIM. So you spend all this money with consultants to create these data-rich models that that there's no further life of the data inside those models. So procuring data that just goes nowhere is a waste that you want to try to avoid. So setting a database is fractional compared to the waste alternative.
No, great. Thanks, Simon. Another question here is, how can this process be used for brownfields assets already in the operate, maintain and overhaul phase?
Yeah, look, a tricky one. Look, the intent of AS7739 was to plug the gap of asset data management over plan, design, build. Most operate and maintain phase, sort of organizations have their own asset management system. It's largely some form of database, but there isn't the equivalent for plan, design, build. So the focus is really project delivery, but for brownfields projects, at the beginning of the job, let's just talk about that. You'd be getting surveyors to survey the site to work out what assets you're going to be impacting, and so this is supplementary to a lot of the activities that would take place for brownfield projects.
Oh, great. Thanks, Simon. Another question here. Will the rollout of IFC5 using JSON files assist with implementing data into our models from an API database rather than doing it manually?
Maybe yes, maybe no. Look, IFC5 has been one of those, it's been like level stage 3 in ISO 19650. It's been sitting over the horizon for quite some time. The change that we're offering here, though, that when I was describing the globally unique IDs, these are globally unique IDs that are owned and managed by the asset or the project client. IFC5 or IFC GUIDs in general are typically used to support BIM software, but that doesn't necessarily have any integration with any other systems outside of BIM software. So the intent of this approach is to actually give the client some control by having reliable, sort of identifiers that support stuff well outside just the typical BIM approach.
Mm-hmm. All right, thanks, Simon. Another question here. What is the feasibility of implementing this strategy in a project that's already in or past the design phase?
The project I'm working on now, design was about 90% complete when I started.
Wow.
And it's now working. So that's not a problem. It's not ideal, but it's not a deal breaker by any means. It's like the best time to start this is to be like, when's the best time to plant a tree 10 years ago? And the best time to start this sort of approach is as soon as you can, really, because it just means that you don't have that sort of like that data loss. But look, regardless of where your project's up to, there's no issues with giving it a go and starting to link things together. Because at the end of the day, like, you got to hand over all this information at the end of the job. So as soon as you can start getting your house in order, the better.
Great, thanks, Simon. Another question here: how does AI affect the need to have structured data?
Yeah, look, I do get this question a bit, and look, it's a fair question. Everyone talks about, well, the future is going to be more AI, and I don't think anyone's going to deny that. AI, though, okay, LLMs aren't necessarily, well, are notorious for hallucinations, and I guess the question is, do you want to be relying on a black box to some degrees to work out your data coordination, or getting AI to interpret the connections between different data sets, or do you want to have some control on it? Relational databases have been around for 50 years, and they are the workhorse for the modern digital age. The back end of most enterprise software these days would still be a relational database, and that's the solution that we're pitching here. AI could easily sit on top of it, but I wouldn't necessarily be relying on AI to coordinate the data association without having the data structured, first of all.
Okay, thanks, mate. Another question here, and this is probably from someone who's just starting. What advice would you give to an IT graduate who wants to start working in this area?
Oh, read the standards, first of all. Just get on board. But yeah, look, it's important to read a variety of standards just to get a sense of, here's what people hold up as what good looks like. But at the same time, I'd also suggest don't just drink the Kool-Aid of what someone else is offering. Just because people say, yeah, this is the best thing we have, be skeptical of everything. Make your own opinions. And the great thing is that you have skills coming from outside our sector. So you bring a fresh set of eyes that may potentially be useful for challenging groupthink. Because I think in my view, I have this opinion that there is a degree of stagnation that's been taking place over the last few years. We need new ideas to help bring out the next round of innovation.
Yeah. And just one last question. What is a good starting point to implement 739 in a project? Is it you looking at training to your project manager or your project team, or would you bring in a digital engineer, just to get that ball rolling? Yeah, what do you think is a good starting point?
Yeah, look, if you want to get started, I could do the sales pitch. Yeah, you get me in, but no, like I'd say, like if you're not sure how to interpret the standard, find somebody that can actually you can just talk to about stuff. It's not the standard was written with a degree of assumed knowledge, but it's not it's not a big ask to get started and learn. But what I wouldn't recommend is let's just do some training on it, or let's just get the project managers reading it and away we go. There is just a small degree of, well, there is a learning curve like anything. Read the standard with an open mind, and then start to consider reflecting on things such as how would you design the digital asset lifecycle in your own organization.
Great, thanks, Simon. Well, that's all we've got time for today. So, look, I'd like to thank on behalf of everyone today, Simon, for your presentation on 7739 and its practical applications. Great presentation, and really appreciate you answering all those questions. The webinar masterclass series is now taking a break until we get back together in February, where we've got a great lineup of presenters already for next year. So have a great and safe holiday period, and we look forward to seeing everybody again next year. Thank you and goodbye.
Thank you.